Terraforming holds the key to making distant barren worlds habitable for Earth life. Mars once held flowing rivers and oceans in the ancient past, evidence that it was once much more Earth-like than the frozen, rust-hued desert it is today. With the right techniques, we could transform and re-engineer the red planet to support life again. First, we would need to warm Mars substantially, likely by emitting industrial gases that thicken the atmosphere and act as a planetary blanket. We would also need to import vast quantities of water, hundreds of millions of cubic meters, probably mined from ice-rich asteroids and comets. Oxygen levels could be raised over time through photosynthesizing plants seeded across the Martian plains inside pressurized biodomes. With basic flora taking root, simple animal species could then be safely introduced. Venus poses an even greater terraforming challenge with its dense toxic atmosphere and crushing air pressure. But the Venusian atmospheric composition could be incrementally adjusted from carbon dioxide to nitrogen and oxygen. Giant shades placed at the Venusian L1 Lagrange point could block enough sunlight to cool the planet's runaway greenhouse effect. With surface temperatures and air pressure lowered closer to Earth-like levels, the colonization of Venus could begin using floating cloud cities. Seeds specially engineered to thrive in Venus's atmosphere could be aerially distributed to gradually transform the global ecosystem. The thick carbon dioxide atmosphere could be processed into solid carbon and oxygen using autonomous robotic terraformers. Over thousands of years, advanced Venusian cloud seeding techniques could create a verdant global rainforest canopy. Some of the most intriguing terraforming candidates are actually Jupiter's and Saturn's frozen ocean moons. Europa and Enceladus potentially already possess most prerequisites for life except surface heat and sunlight. Giant orbiting mirrors could redirect and concentrate solar energy to spark cryovolcanic activity for warmth and water. Genetically engineered lichen and bacteria could be introduced to begin converting atmospheric elements into nutrients. As specially designed plant and animal species establish and spread, subsurface human settlements could finally directly colonize the icy moons as conditions improve. Each world presents unique advantages, perils, and pathways in our epic quest to make cosmic real estate habitable. It may take millennia, but with sufficient will, vision, innovation, and effort, terraforming distant worlds for human expansion is achievable. Now for that secret cheap method to rapidly terraform Mars I promised early on. It involves capturing a rare nickel-iron asteroid passing near Mars, then deliberately impacting it into Mars's northern polar ice caps. This would vaporize the ice and release enormous amounts of water vapor, instantly thickening the atmosphere globally through greenhouse warming. Thanks so much for watching our extraterrestrial terraforming speculation. We really appreciate you taking the time to view the video. It takes us many hours to research, write, record, and edit each one, so your viewership means a lot. If you enjoyed it, we'd hugely appreciate if you could give this video a like and leave a comment with your thoughts below. Subscribing would also help tremendously, as it lets the YouTube algorithm know you want to see more semi-sci-fi content like this. Lastly, sharing this video with any friends or on social media would be extremely helpful for our tiny channel. It really assists with reaching more viewers. So if you know anyone else who's interested in terraforming or making other worlds habitable, please share. Again, thanks so much for choosing our channel. We create this speculative content all for you, our viewing community. So we're grateful for every bit of positivity and engagement. Looking forward to seeing you in the next video soon.